Hello, I'm Neil Knobloch,
I'm Hui Hui Wang.
and today we're going to walk through another module. This is module number 5 in this series of modules, focusing on agroecosystem thinking and STEM, using STEM through ag, food, and natural resources as a way to do integration. After this module, you'll be able to explain the agroecosystem thinking model. You'll describe different collaborative teaching approaches that can be used to implement the agroecosystem thinking model. And then third, you'll be able to adapt the agroecosystem thinking model to example lessons / ideas of integration using ag, food, and natural resources as a way to integrate STEM. So first, we'd like to begin by sharing that agriculture is an excellent way to introduce students to STEM and integrating STEM because it provides many different complex problems that students can engage in. And you'll see that on the left-hand side, what we mean by a complex problem is that these are grand challenges that have an agriculture, food, or natural resources connection, such as food safety and security, sustainability of water and energy, and a number of other complex issues such as climate variability, and they're interconnected with other disciplines in the real world. And so this grand challenge, agricultural grand challenge, really provides a foundation that we are going to refer to as the agricultural context, because they provide some real world context for students to engage in more complex problem solving and using interdisciplinary approaches and collaboration to try to solve those problems. You'll see that students recognize that there are different dynamic components in the system and how those components play a dynamic role with each other. The second thing you'll see is that these complex problems develop 21st century skills such as systems thinking, critical thinking, decision making, evidence-based decision making, collaboration, teamwork. All of these 21st century skills are part of knowing how to cope with complexity and being able to solve these real-world complex problems. And third, the reason why agricultural complex problems is important is because it helps students make scientifically sound decisions. As mentioned in previous modules, there's scientific inquiry methods that are used. There's also engineering design methods that are used. And we're going to now layer another approach, and that is using a systems thinking approach to make scientifically sound decisions. So the work of this model was developed based upon two grant-funded projects that we received and currently have in process. And so the idea of local STEM was having students and their teachers connect with a university research farm, happened to be in Northwest Indiana, and there they could see scientists actually solving these real-world problems in their local community. And those problems then became part of a school-based problem-solving context with hydroponics. And so it really helped the students see how there are many challenges in trying to grow plants or leafy greens hydroponically in a pre-harvest setting. But then once you harvest the product, then there's also a number of challenges, especially related to grand challenges, that they have to focus on and keep in mind in solving these challenges using the STEM content. So local STEM and the Envision project really became the context of how we were able to demonstrate how to walk teachers through this process so they can then walk their students through this process of looking at the food supply challenge from a systems approach from pre-harvest to post-harvest. We begin with sharing this model by looking at the different disciplines of STEM and agriculture, as we have referenced here, the STEAM model or layer of this model. This is where you have core content knowledge that are practiced, as we mentioned in a previous module, number 2, from different disciplinary perspectives. As these come together, you'll see that there's an integrated approach what we refer to as iSTEM or integrated STEM, and also learning about where food comes from, we'll refer to as agriculture and food literacy. So this is where you have the connections that are starting to happen because you're blending the different disciplines together, where STEM and Ag, Food, and Natural Resources becomes multidisciplinary and interdisciplinary in a learning experience for students so that they can now start to see that problems are woven together from various disciplines. They aren't just contextually based in science. Problems are not just based in engineering alone or mathematics alone, but really they're being solved because they exist in the real world and they need to have multiple disciplines working together to help solve those problems. As we then start to think beyond the integration, the iSTEM blending disciplines, we now need to think about how is this relevant to society and how is this relevant to people? And so this is the 4 different strands of system thinking that we'd like to introduce to you. So these Ag, Food, and Natural Resource Design Challenges actually now teach or introduce students to agroecosystem thinking from pre-harvest to post-harvest. And in the particular projects that we're talking about, as mentioned, we've used hydroponics. When you harvest the leafy greens, you now have food safety and technology. And then you can also integrate different technologies such as robotics or sensors to now try to monitor what's going on in both the pre-harvest and the post-harvest components of that system. So let's just think about this. If we were to grow some plants using a hydroponic system, what would we want to think about in a systems way? Well, we would think about what do we need to grow the plants. So we would need inputs, need water, we need light. Light is going to be driven by electricity if it's going to be inside, or I guess it could be by sunshine if it was outdoors, but hydroponics typically is done inside. You also have the different components of the system that need to work. There needs to be oxygen in the water, so there would be a pump. And you could also then start to build in some sensors to monitor the usage of the electricity and maybe the amount of light intensity that's taking place and how many hours the plant is maybe getting from these different inputs. So that is all being done because most people think about, well, if they want to grow a plant, they want it to grow. And so we refer to that one as the production efficiency. So how do we maximize, with these various inputs, how do we maximize the amount of outputs? In this case, it would be in plant growth. When we think about then harvesting that product and we want to sell it, we want to be able to know if we can make money in doing this because we need to pay for the inputs, we need to pay for the investment of the system to grow the leafy greens. And so there's also attention or consideration that needs to be paid for the economic viability, or can this be profitable? Businesses exist because that there's value in producing food or providing services. But those two are in the center because that's typically what most people in agriculture production think about, is how do I maximize my output and how do I make money at this? But we also know that consumers and society, people in society also think about things more than just, is the farmer making money and being productive? They think about, how was this product raised? And was it raised in an environmentally sustainable way? They also think about how it was raised in a socially responsible way. So, for example, some people would not want to eat genetically modified organisms because they feel that there are some health implications if they would if they would consume a GMO product, or maybe they just are concerned about the what type of industry supports that. You also have the use of pesticides in some cases, and some people do not want pesticides to be used in raising the products that they eat or consume. On environmental sustainability side, there needs to be attention to how was the crop raised in a way that actually has less impact on the environment. And so there's a trade-off questions that take place. Were Were the energies from a renewable source? Were the energies done in the most maybe conservative way so that it wasn't wasting any energy within that system? So as we think about the systems approach, you start to see that these four different strands start to work together, and it becomes really a more complex decision-making process of trying to sort out, okay, how do we do problem solving in a way that considers these four different aspects and really done collectively. And then what we do is we also want to build into the system where we have data or evidence, and so that we can make decisions based upon the data. So we call this database decision making. And we do this because we want this to be done based upon science and based upon evidence. And so it's really taking into consideration what evidence can we gather. Sometimes it may be from people, if it's social responsibility. Sometimes it's the cost of the inputs and maybe the revenue for economic viability. We talked about growth and maybe the output on production efficiency. It may be around energy conservation with environmental sustainability. So those are ways we can measure what evidence do we have, so we can now start to try to raise these leafy greens in a hydroponic system in a more balanced way. We also want students to really practice their STEM knowledge and make application by solving these problems, these AFRN design challenge problems, in a way that prepares them to work in the 21st century. So many of the 21st century career skills or workforce skills are going to be developed because students need to learn how to solve problems in a complex, in a system way, with critical thinking, working collaboratively. And so really this model starts to pull together that if they collect data and make decisions based upon the data, that they're going to start to develop these 21st century skills, and again, tie it back to some of the STEM content knowledge that they learned through the integrated experience. So there are, as we mentioned, there are a number of agricultural grand challenges that exist, and we would just like to highlight that one of them would be the use of energy. Energy is a cross-cutting theme in the next generation of science standards, NGSS. And so this is a very useful way for science, technology, engineering, and mathematics teachers to now consider how does a system such as maybe an agriculture food production system, maybe specific, a hydroponic system, try to navigate the challenge of energy consumption, energy conservation, as it relates to the grand 21st century challenge of climate variability, for example. And so this is really about trying to meet the needs of people. Agriculture, food, and natural resources exist because we need to meet basic human needs, and of course food as well as clean energy is part of meeting human needs. And we have the global energy consumption continuing to be a challenge as this will grow 28% from 2015 to 2040. So we're going to have to pay more attention to how much energy we're using to grow our food or even to live, because the demand for energy is going to continue to increase as we see around the world. So the connections of STEM learning really do make a lot of sense when you think about that this overarching theme, this cross-cutting theme of sustainable energy conservation really does connect to a lot of state standards. It's interdisciplinary in nature because it's starting to pull in. It will pull in the STEM areas, and it's going to use agriculture, food, and natural resources as the context, a systems context. And then it allows the students to focus on what does energy mean in a more contextualized, tangible way, but yet it's still part of the big system as they think about the food system. And so it helps to, the Agricultural Grand Challenge helps students actually conceptualize what does interdisciplinary look like as a process as they work through the complex problem solving. And they're able to see this problem as not a simple solution, but something that has a number of considerations that they need to think through, that it's part of a more complex whole as they think about the system in a broader way. Agroecosystem thinking is really based upon what we know as systems thinking. And systems thinking provides a framework to understand the interworking of the system and the connections of the relationships between the different actors of a system. So as you think about any system, you can start to identify a number of different components that make up that system. Even ourselves as people, we have a circulatory system, we have a skeletal system, we have a respiratory system, and so all of that needs to work together. The relationships of how things work together is really a great way to introduce systems thinking to students. We're referring to the agroecosystem as really the context of thinking about this as where does our food come from and how is that raised and how does it really become part of capturing energy from the sun and using natural resources to grow our food. It also helps students to make design solutions that are productively and efficient while also paying attention to the society needs and our own human concerns of being economic and cost effective, being environmentally sustainable, being socially responsible, as well as being acceptable to consumers. As we work through this model, you'll see that database decision making is at the top because we want students to work through the process of complex problem solving so that they make decisions. We want them to do this based upon evidence and data, and we want them to be able to have clarity in the claims that they're making because what they claim to be their decision needs to be based upon evidence. As we know, not all evidence is the same, so there needs to be a discussion around credibility and authenticity and reliability of what the evidence is, and if that actually does support their decision as they work through this process of database decision making. And then there's also a relationship between the design challenges and the claims and evidence that students make because they need to be able to see that the decision they're making is still part of the overall system. So it may be a very specific decision that they're going to raise leafy greens in a specific way with a certain lighting system, but all of that then ties back to it's still part of the design challenge of environmental sustainability and maybe consumer preferences that becomes a part of really supporting why they're wanting to make the decision they're making based upon the claims and evidence that they have to support their decision making. So we want students to really start to see that decision making is based upon evidence in supporting a design decision rather than just making a hunch or gut decision. We really want them to gather the data in such a way that now they're using that as a means to justify and support the decisions that they want to make.
Okay, so let's use hydroponics as example to give you more information about how to engage learners' agroecosystem thinking and database reasoning. There is a new demand for plant-based protein. While people are trying to really pay more attention to their diet. Hydroponics is exciting technology that allows producers to adapt the systems that are managed intensively, but very productive. Hydroponics is a complex system. To create and maintain a healthy, productive hydroponic system, it involves concepts for STEM subjects such as photosynthesis, energy conservation, plant nutrients, and solutions. If you are going to design a hydroponic system that has the best growing condition to generate the best production of living green, many factors can play roles into the system. For example, the best temperature for growing lettuce might not be the best temperature for growing spinach, as well as the hours of the light that are needed. How could you reduce your costs, such as energy, water bills, and labor, and increase your profit, for example, produce more leafy greens? When you designed your hydroponic system, So here is the biggest design challenge that you should consider as a real world examples. Here is combining Module 1 and Module 2. We provide you the two examples how you can collaborate with your colleagues. Remember the co-teaching model? So if you are a math teacher, you can collaborate with your colleagues, agriculture teachers. In your lessons, you can focus on the math design, which you can starting with the scaling, and help agriculture teachers build a hydroponic systems in the agriculture classroom. And agriculture teachers can focus on the management and then cares of the system. So you work with agriculture teacher in his or her classrooms and creating these hydroponic systems, and students are in the both class and working on the same systems. Remember the team teaching models? So here is another team teaching models. You can collaborate with science teachers, and science teachers can help to test the chemistry and introduce the pH ideas with his or her students. And the technology teachers can use the concept of electricity and light in his or her classroom. And finally, a biology teachers probably can use this concept of photosynthesis to teach his or her students in their classroom. So this is the team teaching model. You might not overlap with the students, but all the students will utilize after-school program clubs and to build the hydroponic systems in there, and they can test all the variables by using the after-school clubs on the hydroponic systems that building in there. So now you are going to combining more system level thinkings in here. How could you facilitate system level thinking with your students? For example, you can focus on the management. Increased living green production is a key in the design challenge. You might want your students to focus on monitoring the cost, monitoring the electricity use, which is sustainability, environmental impact, for example, as well as thinking about the social aspect, acceptance for what systems looks like. The management decision that they made will affect the customers and the environment. For example, if students decide to use an insecticide, what type of insecticide is the biological or chemical that they decide to use? How they make their decision and based on what? Because of price, because of its efficiency, because it has the environmental impact. All those things can generate the data points that they help using the data as evidence to help them make their decision. You can also talk about marketing, messaging, packagings in a way that how the customer like, or how do you using those in a more lower price to generate more profit for your product. So those are the examples that if you really think about those that play roles in your hydroponic systems, and those can help you facilitate more system thinkings with your students. Now, you have create your STEM lesson unit through Module 1 and 4. How can you add more environmental, economic, and social consideration into your lessons and units? If you are doing individual teaching like a Module 1, how could you start a conversation with other colleagues to collaborate with you? How the way of thinking in Module 2 help you frame your ideas for interdisciplinary collaboration with your colleagues? So those are the reflection questions that we have after you finish the Module 5. So what are the barriers that you might run into for interdisciplinary collaborations? What are the strategies you think you could use to navigate those barriers to increase and enhance the collaboration with your colleagues? So those are the action steps after you consider those questions and thinking about what do you want to do for the next step. So we'd like to thank our graduate students, Brianna Nielsen. She helped us organize and develop slides for this module, and thank you. So the project actually supported by National National Institute of Food Agriculture, NIFAD, and also the NIFAD and Department of Agriculture. So if you have any question, please contact us and feel free to just having a conversation with us. Thank you.